Something big is happening in the sky above North America right now. A few days ago, weather computers still showed a hot, sticky, stubborn summer pattern that looked like it would never leave. Then, almost overnight, those same computers started showing something totally different. A massive shift is locking into place across the top of the planet, stretching from Alaska all the way to Greenland. And that shift is about to send a rush of cool air plunging straight into the middle of the United States. If you have been sweating through nights that never seem to cool off, if you have been wondering when this endless heat will finally break, the answer is not far away. In fact, the first tastes of it are already being felt right now, today, on August 27th. And the real punch of cold is only days away, arriving as the calendar flips from August into the first few days of September. But here's the part most people will miss. At the exact same time that cool air floods the northern half of the country, dangerous heat is getting worse across the south. The same pattern that brings relief to one group of people brings real danger to another. That split, cool in the north, blistering in the south, is the real story hiding inside this weather pattern. Let us walk through the whole thing, piece by piece, so it makes sense from top to bottom. What is the jet stream and why does it matter? To understand what is happening right now, you first need to understand something called the jet stream. Picture a giant river of wind high up in the sky, miles above the ground, way above where airplanes fly. This river of wind wraps all the way around the Earth, flowing mostly from west to east. It moves fast, sometimes over 100 miles per hour. The jet stream is like a conveyor belt. It drags weather systems along with it. When the jet stream flows in a smooth, mostly straight line, weather moves through in an orderly way. One system comes, drops some rain, and moves on. The next one follows. Everything keeps flowing. But the jet stream does not always stay smooth. Sometimes something forces it to bend. When that happens, the bends can get really big, like giant waves made of wind. And those waves change everything about the weather underneath them. Think of it like a garden hose. When water flows through a straight hose, it goes where you point it. But if you kink the hose, the water bends and sprays in a new direction. The jet stream works in a similar way. When it bends, the air underneath it gets pushed in new directions too. Cold air from the Arctic, the frozen region near the North Pole, normally stays trapped up there because the jet stream acts like a fence, keeping it in place. The fast-moving winds act as a barrier. As long as the jet stream stays strong and straight, the cold air stays bottled up in the far north where it belongs. But when the jet stream bends far enough south, it creates an opening in that barrier. Cold air escapes through that opening and pours down toward places that are not used to feeling it, like the middle of the United States. The bigger the bend, the more cold air spills through. And the longer the bend stays in place, the longer the cold air keeps coming. This is not something that happens overnight. It builds. The jet stream starts to wobble. The wobble grows. A small dip becomes a big dip. And suddenly, air that was sitting near the North Pole a few days ago is sitting over Iowa or Ohio. It sounds dramatic because it is dramatic. The atmosphere can move huge amounts of air across huge distances in just a few days when the conditions are right. That is exactly what is happening right now. What is a blocking pattern? Now here is the key idea that makes this whole forecast work. It is called a blocking pattern, and the name tells you almost everything you need to know. Imagine that river of wind, the jet stream, flowing along smoothly. Now imagine dropping a giant boulder right into the middle of it. The river cannot flow through the boulder. It has to go around it. The flow bends. It buckles. It carves out big loops to get past the obstacle. In the real atmosphere, that boulder is not made of rock. It is made of high pressure. A huge dome of high-pressure air plants itself in one spot and refuses to move. Meteorologists call this a block because it literally blocks the normal flow of the jet stream. When a block forms, the jet stream has to bend around it. And inside those bends, air gets pushed in directions it would not normally go. Cold air that was sitting quietly up near the Arctic suddenly has a path to slide south. Warm air that was sitting in the tropics suddenly has a path to slide north. The normal rules get thrown out. Blocks can last for days, sometimes more than a week. And the longer a block sits in place, the more extreme the weather underneath it becomes. Cool areas get cooler, hot areas get hotter. Everything amplifies. What makes the current situation so unusual is that two blocks are forming at the same time. The double block, two boulders at once. Right now, as of August 27th, 2026, two separate domes of high pressure are setting up at the same time in two different locations. One is building near Alaska. The other is building near Greenland. Picture the top of the globe. Alaska sits on the left side of North America. Greenland sits on the right side, way over near Europe. Now picture a dome of high pressure sitting on each end, like two bookends on a shelf. Between those two bookends is Canada and the northern United States. With a block on the left and a block on the right, the jet stream gets squeezed and bent into a deep dip right down the middle. That dip is called a trough. And inside that trough, cold Arctic air comes pouring south like water flowing downhill through a valley. This double block setup is rare. Having one block is fairly common. Having two at the same time, positioned so that they funnel cold air directly into the heart of North America, is much less common. And that is why this pattern is getting so much attention. The signals that predicted this, meteorologists do not just guess when a pattern like this is coming. They watch specific measurements that act like warning lights on a dashboard. Right now, several of those warning lights are flashing at the same time. The North Atlantic Oscillation. The first measurement is called the North Atlantic Oscillation, or NNOO for short. It measures the pressure setup over the northern Atlantic Ocean near Greenland. Think of it like a seesaw. When the NAO number is positive, pressure near Greenland is low and the jet stream stays mostly flat and smooth. When the NAO number goes negative, pressure near Greenland rises. That rising pressure is the block forming near Greenland. As of this week, the NAO has dropped sharply negative. It dove negative in the final days of August, and current data shows it staying there into the opening days of September. That is not a quick blip. That is a sustained signal telling forecasters that the Greenland block is real, it is strong, and it is staying put. The East Pacific Oscillation. The second measurement is the East Pacific Oscillation, or EPO. This one watches the pressure setup near Alaska and the northeastern Pacific Ocean. When the EPO goes negative, it means a ridge of high pressure is ballooning up over Alaska. That is the other block, the second boulder in the river. The EPO has also gone negative. And here's the part that made forecasters pay extra attention. Both the NAO and the EPO turn negative at nearly the same time. That simultaneous shift is what sets up the double block. A wall on the left, a wall on the right. Cold air funneled straight down the middle. When independent measurements all point in the same direction at the same time, it gives a forecast real backbone. It is like asking 5 different people who do not know each other the same question and getting the same answer from all of them. That kind of agreement is hard to ignore. El Niño, the engine. Underneath, there is a third piece to this puzzle, and it is enormous. Out in the Pacific Ocean, a climate pattern called El Niño is getting stronger, and it is getting stronger fast. Here is what El Niño is in simple terms. Normally, the surface water of the tropical Pacific Ocean is warm on the western side, near Australia and Asia, and cooler on the eastern side, near South America. During an El Niño event, that pattern flips. The eastern and central tropical Pacific gets unusually warm. You might wonder, how does warm water in the Pacific Ocean change the weather over the United States thousands of miles away? The answer is one of the coolest things in all of weather science. When the Pacific Ocean warms up in an unusual way, it changes where big thunderstorm clusters form near the equator. Those thunderstorm clusters are like engines that pump energy into the atmosphere. When they shift location, they nudge the jet stream into a different shape. That nudge travels across the globe and eventually changes the weather pattern over North America. Right now, the Climate Prediction Center says there's a greater than 90% chance that this El Niño becomes a very strong event heading into fall and winter. That is an extremely high probability. It means scientists are about as sure as they can be that this is happening. A very strong El Niño tilts the odds toward exactly the kind of buckled, blocked jet stream pattern that is now forming overhead. The warming Pacific is helping push those 2 blocks into place. It is like a hand on the steering wheel, guiding the jet stream into a specific shape. This matters for 2 reasons. First, it means the pattern change is not random. It is not just the atmosphere rolling the dice and landing on an unusual number. There is a physical driver behind it, a cause that scientists can point to and measure. Second, that driver is only getting stronger as the weeks go on. El Niño events typically peak in the late fall and winter months, so the force that is currently reshaping the jet stream is going to keep pushing in the same direction, which means this kind of pattern could keep repeating in different forms as we move into autumn. Think of it this way. The ocean is the biggest weather maker on the planet. It stores an enormous amount of heat. When that stored heat gets released into the atmosphere in an unusual way, the atmosphere has to respond. El Niño is the ocean telling the atmosphere to rearrange itself, and the atmosphere is listening. The models. Disagree, American versus European. Now for the honest part, because a good forecast has to tell you where the disagreement is, not just where the agreement is. And right now, there's a real disagreement that matters a lot. Meteorologists rely on 2 main computer forecast systems. One is the American model, run by the United States government. The other is the European model, run by the European Center for Medium-Range Weather Forecasts. These are massive computer programs that take in millions of measurements from around the world, temperature, pressure, wind, humidity, ocean temperatures, and use math to calculate what the atmosphere will do next. Most of the time, these 2 models agree on the big picture. Right now, they do agree that a block is forming and that cooler air is heading south into the United States. But they disagree on one critical question. How strong does the block get, and how far south does the cold air reach? The American model leans toward a deeper, stronger block. In its version of the future, the cold air plunges much farther down the map, potentially bringing relief all the way toward the Gulf Coast by the first days of September. That would be a dramatic shift. The European model sees the same pattern but keeps it more restrained. In its version, the cool air spreads across the northern states, but does not push as far south. The deep south stays hot. That gap between the two models is the single biggest question mark in this whole forecast. How that disagreement resolves over the next few days will decide whether tens of millions of people in the southern states get any relief at all, or whether they stay locked under dangerous heat. Here is how to think about it. Neither model is always right. They each have strengths and weaknesses. The European model has historically been slightly more accurate over long time periods, especially for patterns more than 5 days out. But the American model has made enormous improvements in recent years and sometimes nails patterns that the European model underestimates. When the two models agree, forecasters have high confidence. When they disagree, forecasters have to make a judgment call about which solution looks more physically reasonable. Right now, the atmosphere is offering clues that lean slightly toward the stronger solution. The signals from the NAO and EPO are robust. The El Niño forcing is strong. Those ingredients favor a deeper block. But the European model has good reasons for its more conservative take, and dismissing it entirely would be a mistake. The truth will probably land somewhere between the two. That is often how model disagreements resolve. Reality splits the difference. But even the conservative solution brings meaningful cooling to the northern half of the country. The argument is not about whether cool air is coming. It is about how much and how far south it reaches. Day by day, how this unfolds. Here is where the forecast gets specific. Let us walk through the timeline as it stands right now on August 27th, 2026. Right now, the preview. The first hints of the pattern change are already being felt. Over the past several days, cooler pushes of air have been sliding through parts of the northern and central United States. This is real. People in the upper Midwest have noticed mornings that feel genuinely pleasant compared to the brutal heat of previous weeks. Highs in the northern states have dropped into the 70s, where they had been stuck in the 90s. But here's the important thing to understand. These early cool shots are not the main event. They are previews. After each cool push, the heat tries to rebuild. You might wake up to a nice morning, then watch the temperature climb back up by afternoon. The pattern is not fully locked in yet. It is loading up, building toward its peak. Think of it like a wave at the beach. Before a big wave breaks, the water pulls back. That pullback is what we are feeling right now. The atmosphere rearranging itself, getting ready for the big push. Late August into early September, the main event. The real turn arrives in the next few days, as the calendar pushes toward September 1st and beyond. That is when the double block reaches full strength. High pressure fully anchors over Alaska and over Greenland. The jet stream carves its deepest dip down into the middle of the continent. And a substantial cold front comes sweeping south. This front will not be a preview. This is the wave breaking. For the Midwest, the Great Lakes, the Ohio Valley, and the Northeast, forecasters are talking about temperatures running 10 to 15 degrees below the normal average for this time of year. In the coldest pockets of air, some areas could see temperatures running 20 degrees below average. Take a moment to think about what that means. 20 degrees below normal as summer turns into fall is huge. That is the kind of difference that sends people hunting for a jacket or a sweatshirt they had already put away for the season. Overnight lows in the coldest areas could drop into the 50s. If the American model's stronger solution plays out, a few spots could even touch the 40s. That is a genuine taste of early autumn arriving, while the calendar still technically says late summer, into the first part of September. Looking ahead into the first week or so of September, current guidance suggests the cold front could push even deeper south. This is the optimistic branch of the forecast. If it holds, it would mean a genuine, lasting break from the heat for a much larger share of the country than the more cautious forecast would allow. Each computer model update between now and then will sharpen the picture. The trend has been leaning toward the colder outcome for the northern half of the country, and there are hints that the cool air could reach further south than many initially expected. The other side, dangerous heat in the south. Now, here's the part that most people covering this story will miss entirely. While all that cool air floods the north and east, the exact same pattern does something almost opposite to the southern part of the country. Remember the seesaw comparison from earlier? When you press down hard on one end of a seesaw, the other end shoots up. The atmosphere works the same way. When the jet stream buckles and creates a deep trough of cool air on one side, it creates a ridge on the other side. A ridge is the opposite of a trough. It is a dome of sinking, warming air. And this particular pattern is shoving that dome of heat directly over the western and south-central United States. So at the very same moment that people in Michigan and Minnesota are pulling sweatshirts out of storage, people in Texas, Oklahoma, the Deep South, and the Desert Southwest are getting hammered by relentless, dangerous heat. This is not a small detail. The Climate Prediction Center has issued warnings about extreme heat and fast-building drought across the southern United States. Here is why that drought part matters so much. When the ground dries out, it loses the ability to cool itself. Moist soil can release water into the air through evaporation, which takes heat with it. But dry, baked soil cannot do that. Instead, it absorbs heat all day and then radiates it back out, making the air above it even hotter. Each hot day bakes the land a little harder, and that baked land makes the next day even hotter. It becomes a cycle that feeds on itself, and once that cycle gets going, it is very hard to break. In the hottest zones across the desert Southwest, afternoon high temperatures are still expected to reach past 110 degrees and possibly 115 degrees. To give you a sense of what 115 degrees feels like, a car parked in the sun with the windows closed on a 90-degree day reaches about 130 degrees inside. Now imagine the air outside being only 15 degrees cooler than the inside of that car. That is what 115 degrees means. It is punishing. It is hard on the body in ways that happen faster than most people realize. Across the south central states and the southeast, widespread readings above 100 degrees remain likely. When you add in humidity, the stickiness in the air, the heat index, which measures what the temperature actually feels like on your skin, climbs even higher. A day that reads 100 degrees on the thermometer but has high humidity can feel like 110 or 115 on your skin. That is because humidity prevents sweat from evaporating. And evaporating sweat is your body's main cooling system. And when the air is already saturated with moisture, your sweat just sits on your skin and does nothing. Your body keeps producing more, trying harder, and overheating in the process. That is real danger. That is the kind of heat that sends people to emergency rooms with heat stroke, heat exhaustion, and dehydration. That is the kind of heat that is especially risky for older adults, young children, outdoor workers, people taking certain medications, and anyone without reliable air conditioning. Every year, extreme heat kills more people in the United States than tornadoes, hurricanes, and floods combined. It is the deadliest form of weather, and it does its damage quietly, without the dramatic visuals of a storm. The divide, refreshing and cool in the north, blistering and dangerous in the south, is the true story of this pattern. Where a person lives relative to that dividing line decides almost everything about what the next 2 weeks feel like. Storms, the sound of the pattern. Changing. A big pattern shift like this does not happen quietly. When cold air on the move smashes into warm, humid air that has been sitting in place, the atmosphere reacts, and that reaction is thunderstorms. Over the past few days, this collision has already produced rounds of rough weather, and more is expected as the front continues to push through. But here is the reassuring part, stated calmly and clearly. This is not shaping up to be a major tornado outbreak. The main threats from these storms are strong winds and hail. Understanding why matters more than just hearing a warning, let us break it down. Why these storms form. When you have cold air pushing into warm air, the boundary between them is called a front. Along that front, warm air gets shoved upward. As it rises, it cools, and the moisture in it condenses into clouds and rain. If the warm air is really moist and really unstable, meaning it wants to keep rising once it starts, the updrafts inside those clouds can get extremely powerful. That is how you get towering thunderstorms. A couple of specific ingredients are making these storms strong right now. The first is something called steep lapse rates. That is a fancy way of saying the temperature drops quickly as you go higher in the atmosphere. When air near the ground is hot, but air a few miles up is cold, the difference creates instability. It is like a pot of water on a stove. The heat at the bottom makes the water want to rise. Steep lapse rates make air want to rise, and that feeds thunderstorms. The second ingredient is wind speed increasing with height. Down near the surface, the wind might be blowing at 15 miles per hour, but a few thousand feet up, a ribbon of fast wind called a low-level jet can blow at 40 or 50 miles per hour. That difference in wind speed between the ground and higher altitudes helps storms organize and become stronger. When you combine steep lapse rates with increasing wind speed aloft, you get storms that can build tall quickly, organize into clusters, and race across the landscape, producing damaging gusts. What the storms can do. The Storm Prediction Center has been highlighting several threats. Wind gusts strong enough to snap tree branches, knock down power lines, and cause scattered power outages that can leave neighborhoods in the dark for hours. You do not need a tornado for wind to be dangerous. A thunderstorm gust of 60 or 70 miles per hour can bring a tree down onto a house. Hail large enough to dent cars and damage roofs. Some of the strongest storms could produce hailstones exceeding 2 inches across. A 2-inch hailstone is about the size of a chicken egg. Getting hit by one of those hurts, and it can do real damage to property. Where to watch? The geographic areas most at risk shift day by day as the front moves through. The northern Rockies and central high plains have been seeing storms fire as small ripples of energy in the upper atmosphere move through and trigger them. The upper Midwest, parts of Iowa, Wisconsin, and Michigan, has been another active zone, where storms sometimes start as isolated supercells, rotating thunderstorms that can produce large hail, before merging into a line that becomes primarily a wind threat by evening. The Central Plains and lower Missouri Valley have seen storms cluster and grow into organized systems carrying serious wind potential. Further south, across Mississippi, Alabama, and into northern Florida, a very moist and unstable air mass supports storms as well, though the wind shear, the change in wind speed and direction with height, is weaker there. That means those storms tend to be the pop-up variety. They form quickly, dump heavy rain, and maybe a strong gust, and then collapse. Still dangerous, but not as organized. Looking ahead, the severe weather threat shifts and organizes around the Ozark Plateau and into the Mid-South, with one or two storm clusters capable of producing long swaths of damaging wind. There is also mention of central and southeastern Arizona getting drawn into the action as moisture from the monsoon season interacts with the mountainous terrain. The tornado risk across this stretch remains low. Forecasters classify it as marginal or isolated rather than widespread. If a brief tornado does spin up, it would most likely be quick and short-lived, not the long-track systems you see during the peak of spring tornado season. Why the storms matter to the bigger picture. Here is the connection that ties the storms back to the larger pattern. They are not a separate story. They are the sound of the pattern changing. Every front that moves through marks the boundary between the old summer air mass and the new cooler air trying to take over. The storms are the friction of that transition. Once the double block fully locks in and the big pool of cool air settles over the northern and eastern states as the month turns over, the atmosphere in those regions actually calms down. The sharp temperature contrast that fuels the storms moves south along with the front. Behind the front, the air is cooler, drier, and more stable. The storms move on. A quick word about hurricanes. There has been some chatter about a system out in the Atlantic Ocean, and it is worth addressing honestly. There's a tropical wave, a cluster of thunderstorms that rolled off the coast of Africa that could try to develop. But the odds of it becoming something significant enough to threaten land are currently low. And here is the fascinating reason why. The very same pattern that is reshaping the jet stream over North America is also making the Atlantic Ocean hostile to hurricanes. El Niño does more than just change the jet stream pattern. It also increases wind shear across the Atlantic basin. Wind shear means winds blowing at different speeds and directions at different heights. For a baby tropical storm trying to organize, wind shear is a killer. It tilts the storm, rips apart the tall thunderstorm towers the storm needs to survive, and prevents it from building the organized spinning structure that a hurricane requires. On top of that, if the block setup sends a cold front pushing far enough out over the Atlantic, it can inject dry, stable air right into the path of any tropical wave trying to develop. Dry air chokes a tropical system the same way a lack of fuel chokes a fire. So, while the tropics should never be fully dismissed during hurricane season, surprises can always happen. The atmospheric setup right now is actively working against major tropical development, and that is a direct result of the same forces driving the pattern change overhead. The temperature picture, what to expect. Let us get specific about the actual numbers because this is the part that affects daily life the most. Right now, late August. Across the central and northern parts of the country, highs have been settling into the 70s and 80s. For areas that had been baking in the 90s for weeks, that is a real and welcome step down. Morning lows have been dipping into the 50s and 60s in some northern areas, which makes sleeping with the windows open pleasant again. But push into the central and southern states, and the picture is very different. Readings above 100 degrees remain in play across the south-central states. The southeast is seeing highs in the upper 90s to around 100, and the desert southwest is still cooking, with afternoon temperatures reaching 110 to 115 degrees. Those are the raw air temperatures. Once you factor in humidity, the heat index, how hot it actually feels on your skin, runs even higher. The Climate Prediction Center is treating the extreme heat across the south as a genuine hazard, not just discomfort. Heat at that level can be life-threatening. The rhythm, cool, then warm, then cool again. Each cold front that swings through knocks northern temperatures down a notch, but right behind it, the heat tries to rebuild. It creates a rhythm. A cool morning, then a warm afternoon, then another cool push arrives a day or two later. Each wave of cool air gets a little stronger. Each recovery of heat gets a little weaker. This rhythm continues until the double block reaches full strength and slams the door shut on the heat for good across the northern tier. The big payoff. Late August into early September. The deepest, coldest shot of the entire sequence is the one this forecast is built around. It arrives as August ends and September begins. This is when the coolest air of the pattern drops in, deeper and colder than the previews being felt now. For the Midwest, Great Lakes region, Ohio Valley, and Northeast, temperatures could run 10 to 20 degrees below the average for this time of year. Overnight lows could slide into the 50s widely, with the coldest pockets dipping into the 40s. For context, the average low temperature in many Midwestern cities during the first few days of September is in the low to mid-60s. A low in the upper 40s would be shocking, the kind of morning where you see your breath if you step outside early enough. That is early autumn air arriving, while the calendar still says the very beginning of September. When forecasters compare the shorter range models, which look ahead a few days, against longer range climate guidance, which looks ahead a week or two, there is broad agreement that cooler air is coming. The longer range guidance is a bit less aggressive about how deep the cold ultimately dives. That is the same American versus European model tension showing up again in a different form. The overall trend, the direction everything is leaning, favors the colder outcome for the northern tier. And there are hints that the cool air could push further south than we have seen in quite some time, especially if the stronger block verifies. Who ends up where? When the dust settles, here is a rough picture of what temperatures look like. A large share of the northern and central country lands in the 50s and 60s for overnight lows, with pleasant daytime highs that finally feel like the turn of the season. Areas that had been stuck in the 90s drop into the 70s and low 80s. Areas that had been baking in triple digits may ease into the upper 80s to around 90, but the far south and the desert southwest, sitting directly under the heat ridge, stay hot. If any relief reaches them at all, it arrives late, arrives modestly, and does not last long. What you can do, right now, a forecast is only useful if it changes what someone actually does. Here are some practical things worth doing based on this pattern. If you are in the north, Midwest, Great Lakes, Northeast, Northern Plains, the cool air arriving over the next several days is the real thing. If you have been running your air conditioning nonstop, you may be able to give it a rest soon. Consider pulling out a light jacket or sweatshirt. Overnight temperatures in the 50s or even 40s can catch people off guard after weeks of heat. Enjoy it. Open the windows at night. This is the kind of early autumn air that feels genuinely refreshing. If you are in the south, Texas, Oklahoma, Deep South, Southeast, Desert Southwest, the heat is not leaving anytime soon for your area, and it may get worse before it gets better. Take heat safety seriously. Stay hydrated. Limit time outdoors during the hottest part of the afternoon. Check on elderly neighbors and relatives who may not have reliable cooling. Watch for signs of heat exhaustion, heavy sweating, weakness, nausea, dizziness. The drought risk compounding on top of the heat makes conditions especially dangerous. Dry ground bakes hotter, and fire risk increases. And wherever you are, storm safety. With the pattern transition comes storms. The single most important thing you can do is have a reliable way to receive weather warnings, even at night. A weather radio or phone alert system can wake you when a warning is issued for your specific location. Most smartphones have a built-in emergency alert system that activates automatically for tornado warnings, but you should check your settings to make sure it has not been accidentally turned off. When storms are moving through, bring loose items in from the yard. Patio furniture, trash cans, garden decorations, and kids' toys become dangerous flying objects in 70-mile-per-hour winds. A plastic chair picked up by a thunderstorm gust can go through a window. Park vehicles under cover if possible to avoid hail damage. A 2-inch hailstone hitting a car at terminal velocity can shatter a windshield and leave dozens of dents. Know the sturdiest interior room of your home in advance. A bathroom or a closet on the lowest floor, away from windows. If you live in a mobile home or manufactured housing, identify the nearest sturdy building you can reach quickly, because mobile homes offer very little protection against severe winds. If you lose power, have flashlights ready rather than relying on candles, which are a fire risk. Keep your phone charged before storms arrive, so you can continue receiving warnings even during an outage. If you have medications that need refrigeration, know how long they can safely stay at room temperature. None of this costs anything, and it can prevent a great deal of damage, injury, and stress. For everyone, stay informed. Weather is a moving target. The forecast sharpens every day. Check updates from the National Weather Service, which provides free, accurate, and unbiased forecasts for every county in the country. Their website and local office pages are the gold standard for reliable weather information. Social media can be useful for real-time updates during storms, but it can also amplify hype and misinformation. When in doubt, go to the source. The tropics. Still worth watching, but not alarming. One more piece that deserves attention. We are in the heart of hurricane season, and there's always something to watch in the Atlantic between now and November. As mentioned earlier, the current atmospheric setup is hostile to tropical development. The strengthening El Niño is cranking up wind shear across the Atlantic. which tears apart developing tropical systems before they can get organized. The pattern that is sending cool air into the central United States is also injecting dry, stable air over portions of the Atlantic where storms typically try to form. That does not mean the tropics can be completely ignored. A surprise is always possible, but the odds are stacked against a major hurricane event in the near term. The same forces rearranging the weather pattern overhead are also serving as a shield against tropical threats. Pulling it all together, let us zoom out and look at the full picture one more time. A rare double blocking pattern is forming in the atmosphere. One dome of high pressure is anchoring near Alaska, a second is anchoring near Greenland. These two blocks are being helped into place by a rapidly strengthening El Niño event in the Pacific Ocean, which is altering thunderstorm patterns near the equator and nudging the jet stream into a new shape thousands of miles away. The double block forces the jet stream to buckle deeply over North America. That buckle carves a trough, a deep southward dip, down the middle of the continent. Inside that trough, unusually cold air for this time of year is flooding south into the northern and eastern United States. At the same time, on the opposite side of the buckle, a ridge of heat is building over the south and the desert southwest, trapping dangerous, drought-feeding warmth. 3 independent signals: the negative North Atlantic Oscillation, the negative East Pacific Oscillation, and the strengthening El Niño, are all pointing in the same direction at the same time. That agreement across separate measurements is what gives this forecast confidence. The main remaining question is how far south the cold front pushes. The American model says deeper and more dramatic. The European model says more restrained. How that disagreement resolves over the coming days determines whether the Deep South sees any relief at all. The transition between the old pattern and the new one is producing rounds of severe weather, mainly strong winds and large hail with a low tornado risk. These storms are the friction of the atmosphere rearranging itself. Once the block fully locks in, the storminess settles down in the north and east as the cooler, more stable air mass takes over. For the northern half of the country, this is the break people have been waiting for. The door to autumn is cracking open earlier than expected. Pleasant days, cool nights, the smell of fall arriving on the breeze. For the southern half, the coming days bring the most dangerous heat of the entire season. The same pattern delivering relief to one group is building a trap for another. That contrast, genuine relief for some, genuine danger for others, is the full story sitting inside this weather pattern. It is not just a cold front or a heat wave. It is both at once caused by the same set of forces playing out across the same continent at the same time. And it is happening right now. What to watch next? Over the next few days, every new computer model run will sharpen this forecast. The key thing to watch is whether the American model's deeper solution gains support, or whether the European model's more conservative answer holds. As each new round of data comes in, new weather balloon launches, new satellite images, new ocean temperature readings, the models will recalculate and the picture will get clearer. By the time September begins, we will know which model was closer to the truth. And by then, millions of people across the northern United States will already be feeling the answer firsthand. The heat that felt like it would never end is finally meeting its match. Whether that match reaches your doorstep depends on where you live and how strong this block ultimately becomes. But the direction is clear. The signals are aligned. The pattern is in motion. Something has changed in the atmosphere, and there is no going back to the way it was a week ago. The gears of this pattern stretch from the warm waters of the tropical Pacific Ocean, where El Niño is heating the surface and redirecting energy into the atmosphere, all the way to the frozen top of Greenland, where a dome of high pressure is deflecting the jet stream into a shape that funnels cold air southward. Between those two extremes, the warm ocean and the icy island, sits the United States, caught in the middle of one of the most dramatic pattern changes of the entire year. For those in the path of the cool air, the next 2 weeks will feel like a gift. For those under the heat dome, the next 2 weeks will feel like a test. Both experiences are real. Both are caused by the same forces. And both deserve to be understood, not just as a temperature on a screen, but as a reminder that the atmosphere is a connected system, that what happens over the Pacific Ocean matters to someone standing in their backyard in Ohio, and that what keeps the air deadly hot in Texas is the same pattern delivering sweet relief to someone in Wisconsin. That is the story. It is big, it is complex, it is unfolding right now, and it affects nearly everyone on this continent in one way or another.